Welcome, geometry students, to class today on this Thursday, November 21st. Hope you guys are doing well. I'm actually just now reaching for the mimeopad and turning it on, so give me a second to get caught up. Go ahead and get your notebooks out, your pens, pencils, book, calculators, whatever you need. Pillows, I guess, just kidding. And let's get to work here. Oh, as always, let's start off with announcements. Let's see what we got here. No test or quizzes this week, so I can hear you guys cheering all the way from Hickson all the way to Ringgold. No test or quizzes this week. However, when we come back from break, we will be having a test or a quiz or both relatively quickly. You owe me yesterday's homework. I do not have that in front of me. And I'm not going to try to pull it up like I did yesterday. That was quite a fiasco. So it was yesterday's homework. Now remember, it was a Wednesday yesterday, so you did not have to finish it. So at this time, please turn in yesterday's homework, whether completed or not, and you get an automatic 100. So please take care of that. And then lastly, everything has been made up, all the quizzes and tests, so thank you. I appreciate that, and just in time for you to go enjoy a nice Thanksgiving break. So good for you guys. Guys, I'm here to help you. You know that. I care about y'all, and I want you to learn your math, okay? Now what we're going to do today is we're going to take notes for a nice long time. I know we've had this pattern now for quite a while where I teach and you do homework the next day. And Haley, you're new to our school. To be honest, you're probably thinking that's how we always do it in math, and it's not. Usually I teach and give homework, but these lessons have been really long with a lot of information, and when that happens, I try to break it down. And so it's the same thing again today. Let me grab a drink of water here. My throat's a little rough. So it's the same thing again today. It's a pretty long lesson, a lot of information, so get your big ears on and get your big brains going, and let's learn a lot of math today. And then you will have a copying assignment at the end, which I know you're totally not liking that I'm doing this now, but it's what's good for you, and so we are going to do that. And then tomorrow when you come into class, we'll have homework only, okay? And I'd like you to finish it tomorrow if at all possible, so that you have no homework over the Thanksgiving break, but that's really up to you. Let us get started. Please copy in your notes Trapezoids, lesson 6.5. We're going to start looking today, and it gets a little too big, don't you? Let's fix that. There we go. Trapezoids. We're going to start looking at trapezoids today, and I think you'll find this very interesting, a lot of information to learn, and I'll try to make it as easy as possible and hopefully as interesting as possible. The date today is the 21st. And I apologize. I cannot imagine how annoying it is when I continue to clear my throat right into this speaker, but I just have no choice. My voice is pretty raspy today. Probably from yelling at my kids all day here at the house. I'm just kidding. So here we go. Trapezoids, lesson 6.5, and the date today is the 21st. Let's get started. We need to start off with the definition of what a trapezoid is. Please copy this in your notes while I'm talking. This is the definition of a trapezoid. You will be responsible for that on tests and quizzes. A trapezoid is a quadrilateral. Let's stop right there. That simply means it is a four-sided polygon. That's all that it means. Okay, so a trapezoid is a four-sided figure with exactly one pair of parallel sides. Now a parallelogram has two pairs of parallel sides, even though this one looks like it's been stepped on. And so this is a trapezoid over here. Notice we have one arrow on this line, one arrow on this line. That means that this line here, BC, is parallel to AD. Okay? So if we have one set of parallel lines and it's a four-sided figure, it is automatically a trapezoid. Do you understand that okay? Now I'm going to show you a bunch of quote-unquote stuff about trapezoids, so would you please go ahead and copy this in your notes? I want you to copy in your notes this definition, obviously, and then trapezoid A, B, C, D. Trapezoid A, B, C, D. Please copy that into your notes. Now, now you know I'm going to move on like I always do. It's your job to pause the video. You can always slow it down, but you can't speed it up. So I'm going to go pretty fast here. So let's continue on. I want you to copy this in your notes. Now, let's talk about bases. Okay, let's talk about bases. I am not going to make you memorize this definition, but the bases, if you want to make it, well, not if you want to, you need to make note of this. You need to know the bases of a trapezoid are always the parallel sides, always. So, students, I don't care which way you turn this thing. I don't care if it's like that. Your bases are still BC and AD because they're the parallel sides. I don't care if you turn it all the way around so it's setting on CD like this. CD is not your base. AD and BC are your bases. Okay? So you need to understand that when we say, what are the bases of a trapezoid? It's the parallel sides. Always, always, always. Please don't forget that. Please, students, do not forget that, okay? All right, let's talk about something else about trapezoids. Let's talk about legs, okay? When I say the legs of a trapezoid, I am referring to the non-parallel sides. Now, again, I'm not going to quiz you on this like fill in the blanks, but you need to know this because when I'm giving definitions or theorems or postulates or corollaries or formulas, you need to know which sides are the bases and which sides are the legs. So when I say what are the legs of this trapezoid, it's the non-parallel sides. So BC and AD are the bases. AB and CD are the legs. So this is a leg here. This is a leg here. This is a base here. And this is a base here. And it doesn't matter which way you turn this thing. It doesn't matter. The parallel sides are the bases. The non-parallel sides are the legs. I really can't make it any easier than that, okay? All right. Now let's talk about base angles. Base angles. I would encourage you to write this sentence in your note. I think it'd be very helpful. Each base, I should have typed this in, it should be here. Each base has a pair of base angles. Got it? Each base has a pair of base angles. For example, we'll call this angle 1, we'll call this angle 2. Angles 1 and 2 are base angles. They go together. And how do I know that? Well, this is my base, AD, and notice I said each base has a pair of base angles. So this is base AD, and base AD has a pair of base angles. All right, here's another base up here. Base BC has a pair of base angles. So when I say what are the base angles, you would say angles 1 and 2 are base angles. They go together. Angles 3 and 4 are base angles. They go together. You would not say angles 1 and 3 are base angles. You would not say angles 4 and 2 are base angles. Base angles come in pairs. Base angles come in pairs. Okay? Do you see that? So, should not have done that. There we go. Let me fix that real quick. There we go. So, with that in mind, you should know now what the bases are of a trapezoid. They're the parallel sides. You should know what the legs are. They're the non-parallel sides. And you should know what the base angles are. They come in pairs, in sets of 2, or in a set of 2. And each base has a pair of base angles. So this side right here has 2 base angles. This side up here has base angles 3 and 4. Okay? All right, I hope that makes sense. Let's continue on. Now, let's talk about a special type of trapezoid. And you might say, Mr. Earhart, what do you mean a special type? Well, I can throw any old type of triangle up here, right? Just like that. But a special triangle might be an equilateral triangle where all 3 sides are the same. Or I might have a right triangle as a special triangle. Okay, so we have a special trapezoid, and here it is. Please copy this in your notes. You're responsible for this for tests and quizzes coming up, so write this down. What is an isosceles trapezoid? It is a trapezoid with congruent legs. Not parallel, they're not parallel, they're congruent. They have the same length. Let me give you a picture of this. I think that would be a help to you. Okay, copy this in your notes if you would, please. That's a pretty decent picture of an isosceles trapezoid. Notice I have my 1 and 2 sides that are parallel. So this side here is parallel to this side. And then I'm going to say this side here is congruent to this side here. Okay, that's an isosceles trapezoid. Do you see it okay? A regular trapezoid has one set of parallel sides. An isosceles trapezoid is still a trapezoid. In other words, it still has one set of parallel sides, but the legs are congruent. Let's compare that quickly to a regular trapezoid. Here's a good picture of a regular trapezoid right there. I mean, look, is not this side here parallel to this side here? Sure it is. And it's a four-sided figure, so this is a trapezoid. However, do you really believe that this side here is congruent to this side here? Well, no way. This side right here is longer than this side right over here. Okay, so this would not be an isosceles trapezoid. This would just be a regular trapezoid. This is an isosceles trapezoid because we have two congruent legs. So an isosceles trapezoid is a trapezoid with congruent legs. Very important that you understand that. Okay? All right, let's continue on. Let's take a look at our first theorem of the day. All right, I'm sure you're just thrilled to see this. Let's go ahead and make note in your notes. You're responsible for this on tests and quizzes. Theorem 6.2, or excuse me, 6.12. If a trapezoid is isosceles, then each pair of base angles is congruent. Let me read that again. If we have an isosceles trapezoid, not a regular trapezoid, we have to have an isosceles trapezoid. But if we have an isosceles trapezoid, then each pair of base angles is congruent. It is congruent. So let's pretend very quickly I gave this to you on a test or a quiz, and let's say I put an arrow here and an arrow here. So I know I've got a trapezoid, a four-sided figure with one set of parallel sides, and let's say I said this was a length of 7, and this over here, this leg had a length of 7. Well, if it's 7 and 7, we know this side is congruent to this side. So I know I have an isosceles trapezoid. This is an isosceles trapezoid. Now let's say that I told you this angle here was, excuse me, sorry, this angle here was 80 degrees. And let's say that I told you this angle up here was 100, and let's see, this has to add up to, sorry guys, 360, 180, 100 degrees. And let's say this angle right here was 100 degrees. All right? Well, here's what this theorem says. Are you ready? Now remember, I'm going to tell you right now, guys, I don't care which way you turn this trapezoid, okay? It doesn't matter. It doesn't matter where you turn this thing, okay? This side here and this side here are still your bases, and this side here and this side here, these two sides are still your legs. You've got to remember that. So if this is a base side right here, if this was a base side right here, which it is, then the base angles, here's what it says, each pair of base angles, they're congruent. So if this is 80 degrees right here, then I know this angle right here is 80 degrees. Okay, this is a base, and these two angles have to be congruent. Well, if this is 100 degrees, then this also has to be 100 degrees. Okay, so if a trapezoid is isosceles, then each each pair of base angles is congruent. Okay, all right, I hope that makes sense. Let's continue on. And you can see now why we're not doing homework today other than the copying assignment. This is going to be a lot of information I'm going to give you today. And then when I'm done giving you that information, I'm going to give you a lot of examples to practice this information via math problems. And so that's why I really just want to go over the notes today and give you time to digest this. Okay, Theorem 613 says, if a trapezoid, stop right there. Does it say an isosceles trapezoid? No. So it can be any trapezoid at all. It can be an isosceles trapezoid, it can be a regular trapezoid, any trapezoid at all. If any trapezoid at all has a pair of congruent base angles, then it is an isosceles trapezoid. Okay? So now we're getting into proving that a trapezoid is an isosceles trapezoid. So I'm going to go ahead and put parallel markings here because it says if a trapezoid, so we know we have to have a trapezoid. If a trapezoid has a pair, just one pair, a pair of congruent base angles, then it is an isosceles trapezoid. So does this look like an isosceles trapezoid? No, it does not look like to me that this length here is congruent to this length here. Thus our legs are not congruent. But sometimes on tests and quizzes, I'd like to give you figures that don't look right, so I really test your ability as to whether or not you know the math well and not just looking at its shape and making a decision. So I'm going to go ahead and say that this side, I'm going to go ahead and say that this angle here is 95 degrees. And I'm going to go ahead and state that this angle right here is 95 degrees. Okay, as soon as you see that you have a trapezoid, and we know that we have a trapezoid because this side here is parallel to this side here. So as soon as you see that you have a trapezoid, and as soon as you see that you have one set of congruent base angles, then you know right away this is an isosceles trapezoid. Right away, you know it. That's a theorem that we know. If a trapezoid has a pair, one pair has a pair of congruent base angles, then it is an isosceles trapezoid. We could also look at it like this. If I said this angle up here is 110 degrees, and this angle right here is 110 degrees, are not these base angles? No, they're not, because they're not down here. Hold it, hold it. We went over this earlier. Bases are the parallel sides. So this is a base, and this is a base. So if this is a base right here, if that's a base, which it is, then these are definitely base angles. Sure they are. Base angles are the two angles that lie on a base. So I have a base angle here and a base angle here. Notice they're congruent. So as soon as I realize these two angles are congruent, then I can definitely state that I have an isosceles trapezoid. So this is an isosceles trapezoid. And as soon as I state that, then I know this side here has to be congruent to this side here by the definition of an isosceles trapezoid. So there we go. So Theorem 612 says, if I have an isosceles trapezoid, then each pair of base angles is congruent. And then we kind of do the converse of that. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. Okay? All right. Hope that makes sense. Now, let's see if we can't solve some problems here. Okay? Copy this quickly in your notes, and we're going to find the measure of the other three angles. Let's find the measure of this angle, and this angle. Now, first of all, I'd like you to notice that we have an isosceles trapezoid. How do you know that, Mr. Earhart? Well, I have this side parallel to this side, so I know I have a trapezoid, and my legs here are congruent. This side is congruent to this side. So when you have one set of parallel sides in a quadrilateral and another set of congruent sides in a quadrilateral, then you know that you have an isosceles trapezoid. So we just learned that when you have an isosceles trapezoid, each pair of base angles is congruent. So if this is 50 right here, then this is 50 over here. That's easy enough. And now you're thinking, well, Mr. Earhart, what do we do now to find these two angles down here? Well, remember, a four-sided polygon, when you add up the four inside angles of a quadrilateral, a four-sided polygon, they're always going to add up to 360 degrees. Always. So 50 plus 50 is 100. So I know I have 100 degrees so far. Well, I need a total of 360. So I'm going to subtract 100 out of 360, and I'm left with 260. So I know these two angles here have to add up to 260, but I also know something else. I know they have to be congruent. This angle here has to be congruent to this angle here. Why? Because I have an isosceles trapezoid, and isosceles trapezoids always have congruent base angles. So I know these two angles here have to add up to 260, so divide that in half. I know this has to be 130 degrees, and I know this has to be 130 degrees. By the way, if you take 130 plus 130 plus 50 plus 50, you will get 360. You will get 360. All right, let's try another one. Why don't you try this one on your own? I'm going to go ahead and keep teaching, but if you want to pause the video, quickly try it on your own, and then look up at the screen and see if you got it right. Feel free to do that, okay? It's up to you. But we're going to try to find these three missing angles. This angle, and this angle. All right? So you can watch me do it, or you can pause the video and try it on your own. That's up to you. Okay, let's find these three missing angles. Now, first of all, I would like to point out to you that we definitely have an isosceles an isosceles trapezoid. And I know that because I have one set of sides parallel and another set of sides congruent. So I know that I have my bases being parallel and my legs being congruent, so I know that I have an isosceles trapezoid. So as soon as I know that, I know my base angles are congruent. So if this is 100 degrees right here, then this angle right here is also 100 degrees. Okay, now let's add those two together, and we're going to come up with 200 degrees. Now all four angles added together have to equal 360. Okay, and we know that. So I'm going to take 360, subtract 2, sorry about that, my pen is messing up, and subtract 200, and I'm left with 160. So I know if I take this angle here and this angle here and add them together, they have to equal 160. And I know they're also congruent angles, so I'm going to divide 160 in half, and I would have 80 and 80. And by the way, if you take 80 plus 80 plus 100 plus 100, you will come up with 360. All right, let's continue on. Let me grab a quick drink of water here. And let's see if we can't continue on. We're now going to take a look at a new term. You are responsible for this, so please write this in your notes. And again, wow, Mr. Earhart, a lot of notes you're giving us. I understand, but I'm not giving you homework tonight. So that gives you time to copy these over and to really think on these things and make sure you understand them, okay? Mid-segment of a trapezoid. Mid-segment of a trapezoid. What is it? It's the segment that connects. Now listen to me. What does it connect? It connects the legs, but it does it in a special way. It connects the legs in such a way that it connects them at the midpoint of the legs. Let me show you what I mean. See this mid segment here? Let's get it out of the way for a second. Okay, here's a trapezoid, and you might want to write this figure in your notes. You might want to draw this in your notes. Here's a trapezoid. Everybody see it? We're good, okay? Here's a trapezoid. Now, this is a leg right here, and this is a leg right here. I know that because these two sides are the non-parallel sides. So leg, leg. Now, on this segment, there has to be a point that cuts the leg right in half, right in the middle, and it's right there. And on this leg right here, there has to be a point that goes right in the middle, and it's right there. Those 2 points are where this mid-segment line has to intersect, okay? So anytime you're told, now listen to me, anytime you're told that a certain line is a mid-segment of a trapezoid, that means this segment here will be congruent to this segment here because this point's right in the middle, and this segment here will be congruent to this segment here because this point is right in the middle of this whole side over here. Okay, so once again, what is a mid-segment of a trapezoid? The segment that connects the midpoints of the legs. The segment that connects the midpoints of the legs. Hopefully that makes sense, okay? Let's continue on. All right, this is a formula you need to know. Would you please write this in your notes? This is a formula you need to know. Would you please write this in your notes? And I'm going to show you now what it stands for. MS stands for the mid-segment. So as you write this in your notes, make note of that. MS stands for the mid-segment. B stands for one of the bases. It doesn't matter which one. I just called it base subscript 1. It really doesn't matter which one. And then base subscript 2. So each of these B's stands for one of your bases, and MS stands for your mid-segment. Now, here's the thing. Whenever you know both bases, the length of the bases, you can always find the mid-segment. Or, listen to me, if you know one of your bases and the mid-segment, you can find the other base, the length of the base. And that's what this formula does for you. This formula allows you to do that pretty easily. Okay, let's pull that down here. And here we go. Now, I want us to find the length of BE. We're going to call it X. So I want us to find the length of BE. Now, do you see 2 marks here and 2 marks here? Sure you do. Well, that means this is the midpoint of the leg. And you see 1 mark here and 1 mark here? Sure you do. Well, that means this point here is the midpoint of DF. Okay, so it looks like I have a mid-segment because a mid-segment is the line that connects the legs, and this is a leg and this is a leg. It connects the legs at their midpoints, and it does that. So I have a base, a mid-segment, and a base. So I can use this formula. Okay, mid-segment is X, so I'm going to put 2 parentheses X. Everybody see that? Mid-segment is right here. MS stands for mid-segment. I do not know the length of the mid-segment, so I'm going to put X. Base 1 is 13. Base 2 is 15. And by the way, if you turn those around and put the 15 first and the 13 second, it would not matter. It does not matter at all. And now let's solve for X. 2 times X is 2X. 13 plus 15 is 28. And divide both sides by 2. Isn't that simple? As long as you know this formula right here, you will be able to find the mid-segment and the bases very easily. So what is the length of BE? The length of BE is 14 units, okay? All right, I hope that made sense. Let's try. We're going to try 3 or 4 of these pretty fast, okay? All right, here we go. Let's find, notice here now, notice first of all, I definitely have an isosceles trapezoid because I have, or excuse me, sorry, that's incorrect. I apologize. I definitely have a mid-segment right here. 14 is a mid-segment because I have this segment here congruent to this segment here, and this segment here is congruent to this segment here. So as soon as I see that, it doesn't matter whether or not I have an isosceles trapezoid or a regular trapezoid. That has nothing to do with it, okay? But I know that I have a mid-segment because this line right here, this line, is connecting the legs at their midpoint. So I'm going to have to find the length of this other base. Now I know one base, I don't know the other base. So for my mid-segment, the length of my mid-segment is 14. So I'm going to put 2 parentheses and put 14 for my mid-segment. Very easy. And then for one of my bases, I'm going to put 8. And for my other base, I guess I can leave it B. I'm going to put X. Either way is fine. And it doesn't matter if you turn these around. If you put the X first and the 8 over here, it really doesn't matter, okay? And now we're going to go ahead and simplify. For example, over here, 2 times 14 would be 28. So 28 equals 8 plus X, all right? And then we're going to bring the 8 over and make it a negative 8. So when we bring this 8 over and we make it a negative 8, this 8 is gone. 28 minus 8 is 20. Bring down your X. X equals 20. And that is the correct answer. So this base right here, we were trying to find the length of this base, CH. The length of CH is 20. Now I'm going to do 2 more of these. You're welcome to pause the video and do them first, or you can do them with me. I'm going to go a little faster now. So here we go. I know that MN is a mid-segment because I know this segment is congruent to this segment, and this segment is congruent to this segment. Thus, that tells me that MN is connecting right at the midpoints, okay? MN is intersecting the trapezoid at its midpoints. Now, I want us to find the measure of MN. I want it to find the measure of MN. Now, notice MN is your mid-segment, so I'm going to call that X. So for my mid-segment right here, I'm going to put 2 parentheses X, and then for my base, or one of my bases, I'm going to put 8, and the other base I'm going to put 14. Okay, so there's my bases. Well, 2 times X is 2X, and 8 plus 14 is 22. Divide both sides by 2, and X equals 11. X equals 11. Pretty simple. So the mid-segment right here is 11. All right, one more. Here we go. All right, I kind of turned this one around on purpose to make you think, which is good for you. Notice that this side here and this side here, these two sides are my parallel sides, so they're my bases. And then notice M and N are going to be my legs, okay? Now, notice how 8 is connecting the legs in such a way that this point is right in the middle. It has to be, because I've got this segment congruent to this segment, and this point right here has to be right in the middle of this line, because this segment here is congruent to this segment here. So I definitely have a mid-segment, okay? MN is the mid-segment for this trapezoid. I want us to find the length. Let's go ahead and give it some names. I should have done that already, and I apologize. Let's put an A, B, and a C and a D there. I want us to find the length of this base right here, base AB. Okay, so we come to our formula, and 2 times the mid-segment, so 2 parentheses 8 equals, now one of my bases is 6, and my other base I guess we'll just call X. Okay, so one of my bases is 6, and one of my bases here is X. Now 2 times 8 is 16, so 16 equals 6 plus X, and then we're going to bring the 6 over, and when we do it becomes a negative 6. So now the 6 is gone, and we're left with 10 equals X. 10 equals X, okay? So that is the length. If we get an eraser out and erase that, there we go. We will see that the length of this base right here, AE, is 10. The length is 10. I hope that I've not gone too fast today. I hope that you're understanding this. And my phone's ringing here, so I'm going to pause the video real quick. Okay, hope I've not gone too fast. I hope you understand all of this. Go back and watch bits and pieces again that you need to help you, okay? Now this is due tomorrow, guys. I know you don't like it, but it's due tomorrow. 3 times each, okay? They're not big. They're little, small, small, pretty small, pretty small, pretty small, and really small, okay? Definition of a trapezoid. It is a quadrilateral, a 4-sided figure with exactly 1 pair of parallel sides. Isosceles trapezoid. It's a trapezoid, but it's a special trapezoid, a trapezoid with congruent legs. Theorem 612. If you have an isosceles trapezoid, then each pair of base angles is congruent. If a trapezoid has a pair of congruent base angles, then you know for sure that the trapezoid is isosceles. Mid-segment of a trapezoid, that's a segment that connects the legs at their midpoints. Okay, and then this formula, 2 times the mid-segment equals base 1 plus base 2. I hope this has been a help to you. I hope you're working hard. If you have any questions, don't hesitate to call or email. Have a good rest of the day.